Okay, so this is another example where we're going to be playing around with data. We're going to be creating some new columns and trying to understand data formats a little bit more. So as before, we're going to load in the customer data, and you all know how to do that by now. So I'm not going to go through that in any great detail. Okay, so the customer data set has two columns, one with spending in 2021 and one with spending in 2020. So maybe we want to find which customers have increased their spending and which customers have decreased their spending. Um, and maybe work out why or give a certain promotion to consumers we're worried that we're losing. Okay, so we're going to create a new variable called spending diff, and it's just simple algebra where if you've got numeric variables, you can do any sort of numeric operation. So you have spending 2021 minus spending 2020 gives the difference in spending. Now let's just have a look at the head, the first few lines of this. Or the first few, it's a vector, so it's the first few items. And there you can kind of see, you can see the difference there. Let's just see the whole thing. Yeah, so that's the difference in spending between the 2 years. Now, what we're going to do is we're going to convert to a percentage and then round. So what we're going to do is we're going to my data dot spending diff divided by in the base year, which is 2020, times 100, which is a percentage. So it's just a simple percentage difference divided by the previous, which was spending 2020, times 100. So it's the percentage difference. And then round basically rounds this to 2 decimal places. And there we go. That's the percentage difference. And again, I think this is what data, this is not a real company, this was generated for the book because it all looks very, very nice. You don't have any customers completely dropping out or anything like that. Now we're going to actually turn it into a string and we're going to add a percentage in front. Paste basically pastes anything together into a string. So I can paste, let me just do an example. 1A, oh, that wouldn't work, plus comma 5. We don't need the quotations on the numbers. And there we go, that's our new string. And you notice I've got spaces between them. This actually says you've got a thing called separator, which actually usually defaults to a space, but we could get rid of those by putting sep equals plus. Again, if you're not sure how a function works, just question it. And that gives you, again, it gives you some examples here. Okay, so we've basically want to do is we want to add the percentage to all of these. And let's just look what we've got. We don't even need to do the head. We could just see. Okay, don't know what I did there. There we go. That's our newly formatted percentage. Now, if I was putting that in a report, that would be fine. My personal preference is if I'm storing in R, just keep it as numbers because you can't do any further analysis with that data now because the data has been converted into a string. But again, it shows us a few new functions we've not covered before. And again, we could just look at the first few values. I don't like that space. Let's just, I don't care what the book is doing. I want to get rid of that space. Okay, and that error is a learning experience because it actually just took the previous value and then added another question mark. So we need to go back to the creating it. There we go. We just had to reset the original variable, and I think that looks a little bit better. Okay, another thing, sometimes we want to actually log a variable, either it increases too much or we have a lot of outliers. So if we had if we were doing a graph of home prices and you had like a load around 100,000 and then some huge mansion of 10 million, that would really kind of squash the axes. So sometimes we want to put them in a log scale. So let's just have a look at my data.income. And again, we've got some income data here and we want to just compress it. Let's just show what that does. There we go. And again, you would really only use this if you've got, sometimes you need it for regression to remove something called heteroscedasticity, which we'll cover later in the class. But mostly it's to put things on a more meaningful scale. And we probably wouldn't do that in this instance. Okay, so the last little example, we recall from the previous example, we know how to format dates now. So we're creating a new date based on the birth date, so that my data has a birth date. And what we're going to do is we're going to use the birth date and we're just going to convert it to date. So this is what we did in the other exercise. Just convert our weird date format into, so let's just do str now after we've done that, into an actual date. But with my data, not my date. And you see here, birth date is a date format. Now, if I want to work out how old I am as to the current day, well, what's the current day? Well, that's going to be, the day I've done this video, 8th of the 30, 2022. And so I've just created the date for this date. So let's just do that. So your age is the current date minus the birth date. Now it's hard to add and subtract dates. So we actually have a function, it's called diff time, that will basically find the difference between two times or dates. So let's just do, just so we know what this function does. Here we go. And then you could actually set the units. So what we're doing here gives me the time difference in days. But we want it years, so we divide by 365.25. And you see, I was thinking, why didn't they do it using years? But in fact, initially, but then if you look at the units on this function, there is no years, which is why it's been done by days, so we divide by that. Anyway, so we now have the actual days. And let's just make sure that it's numeric. Now, generally, you would say like here, I'm 29 years old. You wouldn't say I'm 29.757. Now, what the floor function does is it rounds, but it always rounds down. The round function rounds up and down, and basically to the nearest number. And the floor function rounds to the bottom. And there's also a kind of a ceiling function as well. So let's just find the floor. So we now have the age of everybody, and we could also take the head of that. So the last little thing, we can also create a birth month. So we have the birth date, And we have functions like in R, so let's just again, we can extract parts of a date object, and we can do things like weekdays, months, quarters. If we really want the Julian calendar, we could get that. But here we just want months. So let's just see what that does. So we get the months. So we set that as the birth month. And there's also an inbuilt list of month names in R. There we go. On a list of like 1 to 12, position to 12. And what the match will do is it'll match my months here to the months in there in this the second array and find the position in the first array. So again, searching the first matches, the positions of the first matches in the second, etc. So let's just do that. And we have the birth month. We know the head will just do the first 10 values, but let's just view the entire data set. And you can see here that at the end, we've got our logged income variable, we've got our percentage spending variable, which again, I would not store like that because it's kind of designed just to look. But the problem is you can't really do much with it unless you convert it back to a number. Then we have this newly created age and birth month. Again, birth month, we could kind of target certain demographics, and birth month, we could use maybe to send a promotion. The month of your birthday will send each customer a promotion. Okay, and that's it. Again, it was just this idea of playing with data, being able to create new variables, and being able to understand data frames.